Today we're going to try marking anodized aluminum with a diode laser. Spoiler alert, it's pretty freaking amazing. Welcome back to Cloud42, I'm James. A couple of weeks ago, I uploaded a video showing a new blue diode laser that I have been playing with. We tried directly marking stainless steel, and we tried using Ceremark black laser marking spray to put some markings on a stainless steel connector panel for the new CNC machine. If you haven't seen that video, I'll put a link up here. You can go check that out and find out more about the laser. We're not going to talk very much about that today. What I do want to do today is try marking anodized aluminum. In theory, the laser should be able to blow the die right out of the anodizing and leave a nice clear mark, and it should be able to do it at a pretty high speed, certainly a lot faster than we were seeing with the stainless. So let's give that a try today. Let me get some sample pieces, let's dial in the settings, and once we've got it so that I think we're going to be successful, I'd really like to put a nice big logo on the front of my CNC mill spindle. And yeah, I know, you can see it back there. That's what we're going to do today. This is the Xtool D1 laser that I showed previously. This is a 10 watt optical output 455 nanometer blue laser. And full disclosure, this laser was provided to me by MakeBlock in exchange for making a video, which I already did. So this one's on me. We're revisiting this because I'm having fun with it. Now you can see a few things that are different about the way I have this set up today. One is I've got these extension legs on it, and these are available from MakeBlock. You can buy them or they may come with the kit depending on which laser you get. And they're just little segments, a couple of inches tall each, and I've got two segments screwed in under each of the corners to raise the laser up because I'm going to be lasering an object that is relatively large, and I need the Z height in order to do that. For my initial tests though, I'm just working on some flat pieces. I didn't want to reconfigure the laser in the middle of all of this, so I've got a couple of 246 blocks here, and I'll just put my parts on top of this, and then when we get to engraving something larger, I'll pull this out of the way and set the parts in here. The other difference on this laser from what you saw last time is I have the air assist attached. This is just a little air compressor and a line that brings the air up and injects it so that it blows out of the nozzle around the laser beam. And this is important if you're going to be cutting or if you have anything that might potentially flame up. Helps you to get a cleaner cut and to blow debris out of the cut and to keep the smoke from building up on the surface. In this case, we're going to be marking anodized aluminum, and it does raise some kind of yellow particulate matter sometimes, and the air assist probably isn't really needed for this, but it will kind of blow that away and get a little bit cleaner engraving. At least that's what I've found. So we'll go ahead and run it. Now to start out marking anodized aluminum, I want to start with some test pieces. I don't want to engrave something valuable on the first try in case it doesn't work out. So I need some little test parts, and one of the things that MakeBlock sent with the laser is this material box that has samples of a bunch of different materials. Wood, there's a self-inking stamp, there's some rubber and some leather, and one of the things they include is a little pack of these anodized aluminum business cards. So these are just little sheets of anodized aluminum in a handful of different colors, and these make great little test coupons. So we'll start with some of these. And as far as settings, they also included a little pamphlet here with all of the sample materials, and here are the metal business cards for the D1 laser, 10 watts. They want 100% power, 105 millimeters per second, one pass. So we will try that as our starting setting and adjust from there. Do you need a material kit like this? Absolutely not, but they sent it, so we'll use some of the materials as test pieces. Well, let's start by engraving one of these business cards. We'll use black because black, obviously. Now, because I'm going to have the air assist on and blowing on this, and this is a lightweight piece of aluminum, I am going to use a couple of pieces of tape, and we will tape it down just to make sure that it doesn't go anywhere during the engraving process. And I'm just going to throw a couple of little pieces of blue masking tape here on the corners. And then I need to make sure I have this straight, and so I'm just going to do this by eye, kind of moving this left and right and looking at the alignment. and I'll just adjust it until it looks right to me. That looks pretty good. Let me turn on the air assist and let's get this thing going. And of course, during this entire process, I am wearing my laser safety goggles. I've got my artwork here in Lightburn, and if we go in and look at it, I am set indeed to 105 millimeters per second, 100% power, and then the line after is also 100% power, speed at 100 millimeters per second, just slightly lower. So we should be ready to go there. I have my origin point set up on the center. Let's center up on this. I will use a scale here to try to get it as close as I can. That looks pretty good. Frame that up, see what that looks like. That's not even close. What is going on here? Minus 17.0, okay, that's fine. Not sure what was going on there. The center wasn't quite right. Let me just put it over here and we'll just frame it up from the corner then. Now I honestly don't know why centering from the center didn't work, but we've got it framed up where we want it now. Let's go ahead and let it run. Okay, now before I move it at all, I'm just going to wipe it here. Oh yeah, we're good. Okay, let me shut off the laser, get it out of the way. And I'll turn off the air assist as well. And let's see what we have got here. I was a little bit concerned because it didn't look very bright, and so let me wipe off the residue. Everything also looks completely yellow because I'm still wearing these. That looks amazing. Look at that. Okay, the one concern that I have is, does it only look this good because these are specially treated cards? This is, something very specific that they provided that works really well with this laser. What about just other anodized parts? Let me go find something else in the shop that's anodized and let's try engraving that. I rummaged around in my scrap bin and I found this. This is a handle of some kind, crank. It had a handle in this end. Yes, I know it's purple. I don't know why it's purple. I didn't make it purple. But we'll set this up. I do know this is anodized aluminum. Whereas with these business cards, I'm actually not sure what this is. Now, I'm a little bit suspicious because this burned out so clean and it looks like nice, clean, shiny aluminum. And I think that generally when you burn through laser etched or laser through anodizing, it turns more white. So let's see if this reacts any differently. So let me just kind of set this up. Oh, and of course my height is wrong. So Let me bring this out. Adjust the height, fold up the little height adjusting leg, and then let's just line this up horizontally before I turn anything on and start making noise. That's good enough for a test piece. Now let's bring this in and get it adjusted pretty close to center. That's going to be fine. We're just testing. And let's frame this. It just wants to come down just a touch. Yeah, that's good enough. Now, one of the things I'm going to do is I'm going to come in here and change the power on this, because looking closely at this business card, I can see that there are some little wavy lines along the bottom from when the laser came whipping around to try to outline it. And same thing on this small text. Going 100 millimeters per second is just way too fast for that. So I'm going to slow that way down, maybe 25 millimeters a second, and we'll just try that again and see if we still get those artifacts. And that's just from trying to accelerate too rapidly. So I'll go over here, fill plus line, and on the line after fill, I'm going to set this down to 25 millimeters per second. Okay, got my goggles. I'll turn on the air assist, and we will let her buck. Oh yeah, and I can already see that is coming out very white, not shiny at all. Oh wow, that looks really good. That looks much more sane in terms of the speed. Oh, wow. Look at that. And I don't see much at all of the little waviness in the lines. There might be a little bit on the text down here. We might still be going too fast to manage this small text, but that looks really good. Now, one of the things I'm noticing here is that there's no residue on this. And so I think, I mean, this thing had residue that had to be wiped off. So I'm really starting to suspect these are not anodized at all. These are probably painted. I also could smell this when it was running, and I really couldn't smell this at all. So I strongly suspect that these are painted and this is anodized. But look at that brilliant white. Okay, well, let's go grab something bigger to engrave, and we'll get to what I really had in mind here in a moment. Now this is what I really want to engrave. As soon as I saw the results that I was getting from anodized aluminum on this machine, I immediately started looking around the shop to see what else was anodized aluminum, and I am pretty sure that is exactly what we've got here on the body of this spindle. This is non-magnetic, this is magnetic, this is non-magnetic. It sure looks to me to be aluminum, so we are going to try marking this with a laser. Now, before I do something big and potentially ugly and life-altering on the front of this spindle, we're going to flip it over, and we're going to engrave on the mounting surface on the back where it's going to be hidden, just as a test, and make sure that the material is going to react the way we want it to react. So let me go ahead and set this up, and we'll go ahead and burn a logo here in the back. Of course, you won't be able to see this part when it's installed, so if it goes terribly wrong, it'll be fine. Oh, and we also have to adjust the height again. Okay, and I'm also, after examining this again under magnification, I can see that on this small text there's still some waviness around the edges, so I want to just turn the outline off completely, and we'll just do the raster scan and just see how that looks. So we'll just change this to only fill. Let me take a quick look and make sure that's going to do what I think it does. Yep, that looks right. And we already framed it up. Get my glasses here. And let's let it run. Now that's not quite as bright as I expected. I expected that to come up a lot whiter than that. I mean, it's a clear mark, and it's easy to see, and it looks nice, but it's not as white as I wanted. Let me just run it again right over the top of that, and just see if a little more energy will lighten that up more. And that made absolutely no difference whatsoever. Let me try one other thing. Let me slow it down a little bit. Just slow it down maybe 75 millimeters a second. I'm going to run it one more time just to see if it makes any difference. If it doesn't, then we'll just assume that that's what this thing can do. Yep, and I'm seeing no difference whatsoever, so I'm just going to stop it. Okay, so on this particular material, the mark isn't super bright, but it is very clear, very distinct. I'm really happy with that. Let's set up and engrave the front. Flip this thing over, and I want to be really, really sure that this is straight on this side. Oh, that's not going to be tall enough, I guess. I'm just going to do it by sight again. And actually, I think that is super close. I'm actually sighting down the back side of this across this back edge and looking at the light reflected from the table behind it, and just looking for that to be nice and even all the way across. And I think we're there. Now, because there's no recess here, this is going to have to be adjusted again. Okay, well, I think we're ready to go. Let's turn on the air assist and go for broke. Okay, that is amazing. Look at that. Yeah, there's just something about this material. This is very similar to the, I assume this is laser engraving here. Actually, it might not be. This feels like it might actually be something on top of the surface or sandblasted, or it might be a laser, a fiber laser or something that marked this. But the color is not too dissimilar from that, and I love it. I love it. Okay, now I need to go get this put back on the machine. Well, I have to say I am really impressed with what this laser will do on anodized aluminum. And it's fast and easy, and it gets good, clean results with very little trouble at all. I have, in fact, spent the rest of the afternoon going around the shop and finding everything I can find that's anodized that I can actually throw under the laser, and I've been burning logos into everything and enjoying every minute of it. I will definitely be using that process some more. I have some questions here that people asked on the last laser video. In fact, I'm realizing I should probably burn a logo into the back of this too. But I'll go through some of these questions and see if I can answer them. First question, does the Ceramark spray work on mild steel? And the answer is yes, it does. Here are some pieces that I did on 16 gauge mild steel, and it works just as well as it does on the stainless. The mild steel isn't as bright, so the contrast isn't as great, but the Ceramark flows out and bonds securely and leaves a really nice mark. So yes, it works great on mild steel. I have not been able to get it to work at all on aluminum. I've tried smooth aluminum, I've tried brushed aluminum, and the laser will not fuse it. The laser just blows it completely off the surface and leaves it nice and clean. And I've not been able to get it to bond. Once you rinse it down, there's no evidence it was ever even there. With the brushed aluminum, it will fuse a little bit down in the scratches, but it flakes off easily. So I've had no luck with aluminum. Maybe there's a way to do it, but I couldn't figure it out. Question 2, what does the Ceramark look like up close? Well, here are some shots under a microscope, and you can see it's a nice solid black mark, and it is fused together securely, and it is securely bonded to the metal. I'm actually quite impressed. It looks just as good under the microscope as it does just with the naked eye. I'm really pleased with it. Question 3, can you engrave very fine lines? Yes, you can. I did not show this in the previous video, but here is a test piece where I've burned single laser lines into, in fact, this is mild steel again. And this is, you can see they've burned in securely. It's nice and solid, it's nice and black, and the lines are really fine. This is a millimeter scale for reference. Question 4, couldn't you just use powder coat paint instead of Ceramark to save money? I haven't tried it, so I don't know, but I don't think so. I searched the web trying to find other people who have successfully done it, and I found absolutely nothing. And that's the sort of thing that I would think would be all over YouTube, hacks to do things cheap. And I didn't find anything. Found a bunch of references to burning powder coat off of the metal substrate. I even found references to burning off one layer of powder coat to reveal a different colored layer underneath, but nothing about actually sintering it on. My understanding is the powder coat paint is mostly polyester, so it's mostly a plastic, and it's gonna just burn under the laser. You need a more gentle heat that heats evenly and in fact heats the metal substrate for several minutes to get the polyester to melt and cross-link and flow out. I don't think you're gonna get that with the laser, but if you manage to get it to work, leave me a comment and tell me how you did it, because I would be interested in playing with it. I would have already tried it, but I don't have powder coating gear here in the shop. Question number 5, isn't dry moly spray lube the same thing as the Ceramark? Yes and no. The pigment is the same. The Ceramark, looking through the material safety data sheet, appears to have molybdenum in it as a pigment. But the vast majority of the material is silica and other glass components, so that it's fusing into a glass or a ceramic and bonding to the metal. Whereas the dry molybdenum spray does have the molybdenum in it, and I have seen examples of people using a laser to bond that to the metal and use it as a marking compound, but it's certainly not the same thing. It's not going to have the glass component. That's the last thing you would have in a lubricant is powdered glass. So I don't have any here right now. I may pick some up and give it a try. But like I said, I don't have any in the shop, so I haven't tried it. So that's all I have for today. If you enjoyed this video, give it a thumbs up. Feel free to subscribe to the channel and leave me a comment. I would like to know what you think. And if you've got other ideas for things I should try with this laser, go ahead and throw those down in the comments too, and maybe we'll take a look at it in a future video. Thank you for watching.